discussing two events today. One is a Tesla news that was kind of controversial. Reuters reported that Tesla apparently wants to scrap the $25,000 car, and wrote an article that kind of sounded like Tesla's scared of Chinese competition, and in typical Reuters manner, just very bad, bait clicky. Elon Musk refuted this article, but in a way that he left stuff open after the close. He tweeted that there's going to be an unveil of the Robotaxi. Now, I think overall, the way we interpret this situation is that Tesla is focusing now on FSD and Robotaxi and things along those lines, and probably is scaling down volume expansion, whether it's because there is not enough demand or whether it's they just want to focus now on FSD and roll that out and make that part of the offering and monetize it and all those things. Uh, in our view, this is definitely a good situation because we think that software is absolutely the key to Tesla's future in almost any kind of context. Um, One sec. Yeah, my FSD actually is just doing some maneuvers here. There's a car that wanted to pass, and a human probably wouldn't have let this car pass, just in terms of how the geometry and that dynamics looked. But the FSD is, I guess, overly cautious and lets him pass. So we had to kind of hand wave and stuff like that. Interesting to see how FSD is working. I think it's definitely L4. Yesterday I was at a Stanford seminar, and for the first time in a long time, I've heard the word Tesla mentioned on the Stanford campus. And it was in the context of basically the two biggest innovations in AI recently have been ChatGPT and most recently the massive rollout of L4 technology by Tesla. So in that context, I think back to the subject, I think it makes sense that Tesla drives this software evolution now into the fleet and drives consciousness. It's also going to be a political fight. So we're going to talk about this in this episode. The other thing we want to mention in the episode is completely unrelated, but this podcast is like that. We do market driven daily stuff, and we do very big picture stuff. The other thing is we've been working on embodied AI for a while now. In particular, embodied decision making agents, so foundation models for embodied decision making agents. And within that context, this is now part 12 of the foundation models for embodied decision making agents. And what we're trying to depict here is actually a very interesting parallel. And the parallel is between what Kaiming He was talking about recently at an MIT conference. He was talking about representation, and we want to draw the line between him and actually Douglas Hofstadter. And I know this might be a stretch for some, for others this might be like duh. It's almost a duh moment, because reading "I Am a Strange Loop" by Douglas Hofstadter, which is basically a clarification of his actually most famous book, which is Gödel Bach. Uh, you know, uh, he's saying in the book, there's a passage where he's talking about representation, and he's talking about how we humans evolved an intelligence which allows us to basically scale very small events or very small relationships into higher level relationships in physics. Now, this is called emergent factors. Douglas talks about epiphenomena. What it means is, if you take let's say boiling water, we perceive it as hot. We know we can cook an egg in it, but we don't know exactly how each molecule is acting in a pot of boiling water. And we don't talk like that. We don't represent a pot of boiling water in molecule space or proton space, or even H2O space, whatever. We talk about it as it's just boiling water. Let's leave it at that. Recently, there's another related example. Dorsa Sadik spoke about a different context, but she spoke about semantics in embodied AI, and she said that the problem with I think masked autoencoders, right? The problem with masked autoencoders, which by the way is what Kaiming evolved. I mean, he's the author of the masked autoencoder uh, paper, which then proliferated this idea of masked autoencoders for visual representation. Anyway, the point is, what she said is, if you don't have semantics, you don't really understand that orange juice and milk are the same thing as far as pouring into a glass is concerned, right? So it's obviously not the same thing if you make a screwdriver drink, which is vodka and orange juice, but it's the same thing for a robot when it comes to pouring that stuff from a jug into a glass, right? So in that sense, we humans or intelligence in general from the point of view of the AI community, always, by the way, has been about representation. And Kaiming actually mentioned something really interesting. He mentions that Jan LeCun and Benjo and these guys back in the late 80s, when they were developing their sort of state of the art networks that even are used today, such as convolutional neural nets and things along those lines. When they were developing those things, the AI community was really not very receptive, because what the AI community was saying was, you can't do this. Like, you need different types of representations. So the AI community was right for the wrong reasons. What they said was, we need higher level representations. You can't just learn from data. What the what the neural net guys said, though, was, yes, we understand that, but what we think we can do is we can develop representations from data by using forward and backward propagation and learning, and that is fundamental. There's another thing that Douglas mentions, which is the concept of looping, which is very interesting. What that means is, in the book, actually, Douglas talks about the risk of an eternal loop, right? So, for example, I mean, just one example would be if we had eternal loops, let's say, in sound, right? If you've ever been to a live concert, you know what it means when sound starts looping. It's that noise that microphones create. Imagine if that was infinite. It would get to a point where the sound wave would destroy the whole universe. So clearly, there's some sort of regularization happening in nature, which prevents these loops to get eternal. And this same regularization or normalization is exactly what the AI community has developed in dealing with this looping. In the AI community, it's just called diminishing gradient or exploding gradient, things like that. But it's the same concept. If you learn from data, and let's say you start doing forward and backward propagation, you run the risk that certain information gets amplified and amplifies itself, and then sort of becomes a self-fulfilling prophecy. And next thing you know, that one data point, it's kind of like almost like the butterfly effect in chaos theory, where you have one little effect, in the case of AI, maybe one little data point, one X, which gets fed into this function optimization network, the neural network, and then that little X turns into the main factor that drives the neural net, and totally sort of screws up the predictive power and the actual learning process. We've dealt with that in the AI community by introducing regularization and normalization and thinking about initialization. All these things are meant to deal with the fact that we want to use the inputs of a neural net in more relative terms and not absolute terms. This is what it really means, because what we really care about is patterns. We don't really care whether X, let's say, in a pixel in a picture of a cat, whether that one pixel is really red or just a little bit red. What we care about is that the pixel is not yellow like the pixel next to it, and we define that by developing an edge, and that edge is something that we use in representation, and so on and so forth. So in this episode, I'm going to talk about two things. One is the Tesla situation, and the other is this idea of representation, which I think is, according to Kaiming, is fundamental to AI. But it's also interesting to look at this whole movement of embodied intelligence in particular. It's not just embodied intelligence, but since we're focused on embodied intelligence, let's just stick with embodied intelligence. Let's ask the question, what is optimal representation? How can we get better at it? How can we avoid mistakes? What is Tesla's situation as far as embodied AI is concerned? Things along those lines. This is the Not Even Wrong podcast. It's April 5th, 2024. This is Grim Delco. For the day, the fund is down 1.8%. The market is up 1.2%. For the year, we are down 21.6%. The market is up 10.2%. We're underperforming by 31.8%. Now, the problem, let's start with Tesla. So why is Tesla down today? It's because there was news by Reuters that they will scrap the Model 2, and that's because of Chinese competition. In our opinion, that's nonsense. The reason the Model 2, which is a $25,000 Tesla, is being launched is to actually combat Chinese competition. So that is already a sort of a red flag that the reasoning doesn't make sense. You could potentially slow down the rollout of this car for other reasons, such as, for example, push level 4 software now, things like that, which we will talk about. But the reasoning itself just sounds very suspicious, and we believe that there's not too much truth. There's some truth to this, but it's being totally misrepresented. Here's the situation the way we see it. Tesla is planning to launch a low-cost car. Let's define what that means. The reason Tesla is launching a low-cost car is not so they can have a cheap car. People are actually talking about, let's say, having the availability of Model 3s now almost like for $40,000. And if you want to go secondhand, you can buy cars for $30,000. So you're already very cheap, yes. But what Tesla is trying to do is two things. One, they want to make a car that costs $20,000 to make and can be sold for $30,000 and has the value of a $50,000 or $60,000 car. So they want to add not just lower cost, but also add value. For that, they need to do some R&D. They need to figure out, let's say, how to do one stamp versus parts welding. So can we just stamp one big part and then add all the stuff? This would reduce the cost of production massively. The 48-volt architecture of the Cybertruck is a predecessor of what this car will look like, because with 48 volt you have a lot less cabling, you have much better internal software, things like that. We've been always of the opinion that Tesla is a software-defined car company, so therefore the software side, the networking side, the chip side, and the car manufacturing, all of these things matter, but it's certainly not just the car company. And the $25,000 car is paving the way for a car that can be built at lower cost and produce a lot more value, which is really how you gain market share and dominate markets. Let's not forget the mission of Tesla. It is to basically to replace the ICE car fleet with electric cars, and the best way to do that is to offer lower cost, higher value. This is the best way. You can get entangled in political conversations, in posturing, all of those things. You can fight the naysayers, the haters, as much as you want on X or in the news media or whatever. The best way to win any kind of battle, such as the one that Tesla is fighting, which is really to replace emissions from gasoline cars with something that certainly also has emissions, but very different types of emissions, and probably is much more fun and much safer to drive on top of that. So having said that, the second reason, and the most important reason we believe that Tesla is actually building this car, is also to prevent disruption from below. In other words, the risk that Tesla is facing from a competitive perspective has always been the cheap, low-cost car manufacturers from China / Asia. Let's add Korea there, and who knows, maybe even other car companies could potentially threaten Tesla's electric car dominance. The way you fight the threat of low-cost competition is by also being low cost. That is, Clayton Christensen 101. You cannot go off market. That's what the Germans are doing. That's just the wrong way to do it, because that's exactly how disruption happens. You start going off market. You say, well, okay, fine. BYD and Kia and so on and so forth. Let them have the low end. We will just go for the high end, and this is exactly what's happening now. Mercedes, BMW. You have little crystals in the car, leather seats, this and that. The car is super expensive. It's being subsidized for now, but clearly it's way too expensive for any kind of competitive situation. So in the long run, these types of things always fizzle out, and the low-cost manufacturers win. So Tesla, as a longevity preservation type move, is doing R&D on trying to make a low-cost car. For that, they need to not just innovate in the car and the design and the software, but also in the manufacturing technology. And this is what they're doing. This is exactly where we stand. So having said all of that, today there's the news that, again, Reuters said they're scrapping this whole project. The truth is probably more that they're slowing down, and they're not slowing down because of Chinese competition, but they're slowing down because they're changing their priorities. This is really important, right? Companies change their priorities. There are, startups, particularly companies like Tesla. They do that all the time. They look at the marketplace, and most importantly, also they look at what's available on the technology front. And particularly in Tesla's case, they actually evolved the technology that is, in my opinion, going to define the future of the company, which is L4 driving technology, FSD, version 12.3, which is what I'm driving right now. It's L4. Let's leave it at that. This is not up for debate, right? This is not. I believe the software is this. I'm driving it right now. It's happening. It's real. And very often when we have this type of technology, we might overestimate the short run, underestimate the long run. I don't care. One thing is for sure is that we forget how amazing this is because we get used to it very fast. And this is one of those situations. Whether this is a GPT moment, or ImageNet moment, or the World Wide Web moment, or whatever moment it is, or iPhone moment, or it's a moment. And I think this is the L4 moment of Tesla. In my opinion, it's going to drive lots and lots of car makers out of business, because this is now software defined for real. Like if you were doubting that Tesla is a software defined car company, that if people thought that Tesla's just a car company and forget the software, who cares about software, right? You could have said that. My brother bought some car, Volkswagen or something, electric, and claims it's the same like Tesla, blah blah blah. I gave up trying to argue, and the charging's a little less convenient, the map's a little less convenient, the integration's a little less convenient, but yes, it all adds all up. But who cares? But now this is different. You know why this is different? I wake up in the morning, I take my kid to school, and there it says software update. You were just granted a 1-month free trial for FSD version 12.3. So overnight, probably it took about 30 minutes to upload that software. My car learned how to drive. This is software-defined car. This has nothing to do with car. This is software is defining the car, because my car is now a different product than before. And by the way, it's a lot more valuable than before. Now, whether Tesla can monetize this, whether we can get those trillions of dollars in market cap, that's a whole different conversation. And for another episode, this would definitely, I don't have that much time here, and I don't want to also engage in that conversation now. I should, because I'm a hedge fund manager. I'm not a technology analyst or journalist. I get it, but I'm not, because again, I have other things to discuss here. So let's leave it at that. This is game-changing technology. It's amazing. And what's amazing about it is not just the customer experience, but also the fact that it's going to get better and better and better, which is that loop that I'm going to discuss in a few minutes. that was Hofstadter is talking about, and Kaiming He is talking about, the essence of deep learning, the essence of AI, the essence of this thing that we call AI today. The essence is that it's a loop that amplifies itself. And if it's managed properly, it's going to get better and better and better. The definition of an AI company is a company whose products get better by usage. This is exactly what I'm doing right now. I'm using the product, which is a Tesla, driven by FSD version 12.3, and I'm improving the car because I'm improving the software. The way they're doing this is, amongst other things, by shadow mode. But again, that's a whole other conversation also. So fundamentally, what we believe is happening with Tesla is that they're reprioritizing their efforts and resources into driving this L4 into the marketplace, monetizing it, all of those things. Musk announced that they're going to reveal a Robotaxi. What that means and how that's going to work, all of these things are out in the open. You could also see a combination of the $25,000 car being a pure Robotaxi. There's a conversation of whether that car even has a steering wheel. There's a conversation of how regulators will approve this. In my opinion, the best way to proceed from a Tesla strategic perspective is to find beachheads such as Texas, Singapore, Estonia. Find a place and launch this Robotaxi, and then go from there and see how you can iterate and get better at it. So this is the way we see the situation. It's uncertainty. I think it's okay for the stock to be down. I think it shouldn't, because think about the potential value creation here. I think in the market we always have to look both ways. We don't do that very often. We get sort of people like to have binary mode when it comes to markets. So either you're negative or you're positive. Right now everybody's positive on Nvidia, and right now everybody's negative on Tesla. This will change, and this L4 technology is massive value creation for Tesla. It's unforced errors that could potentially derail that, but the technology is there, and why should we doubt this company? The company, and if you add SpaceX and Neuralink, but particularly SpaceX to the equation, there's no reason to doubt that the engineering talent under Musk is not going to be able to develop a massive wealth-creating technology. So this is where we stand as far as that's concerned. What exactly is going on, what the rumors are, and things like that, you can check that on various websites. Let's talk about the other thing. So Kaiming He gave an interesting talk at I think it's called Deep Learning Bootcamp at MIT. Now, the talk is about 1 hour talk. It's a really nice, comprehensive history of how deep learning evolved from the lens of representation. Now, it's a bit of an unhappy word. The thing that describes representation is really the essence of deep learning, and that is you take whatever input you can get, pixels, sound waves, words, whatever it is, that's how nature works, right? Whatever input you can get, sensory input you can get, the goal is to capture that input, of course. We have cameras for that. Humans have eyes for that. But then the goal, the brain, or the idea of the whole exercise is to find an optimal representation of that data so it can be used for inference and other things. That's all deep learning is, according to Kaiming. And he goes in his presentation. It's really interesting. I'm going to actually discuss it a little bit more formally because it's so key. Kaiming is one of those. This is a tangent now. He's one of those researchers. There's a few researchers in the AI community, in my opinion, that are worth listening to. So if you're somewhere at a conference and you have one of those names on the keynote panel or something like that, go. You're not going to waste time. So here's the list of names: Sergey Levin, Jitendra Malik, Peter Beal, and Dhruv Batra, and Kaiming He. I've left out some names. Dorsa Sadik, Stanford is amazing. Dieter Fischer, UW is great, and there's many more, many more. This is just my narrow view. I'm doing a sabbatical here at Stanford now, so clearly I'm Bay Area or focused. But the Berkeley people, Beal and Malik and Levin are outstanding. Just look at their H index, you'll see that. And again, I think Kaiming is one of those, right? So whatever opportunity you have to meet him, listen to him, participate in the panel, do it. You're not going to regret it. So Kaiming is, he created something, in my opinion, very important, which is the masked autoencoder idea. I'm going to talk about this if I have some time. It's not the key here. The key here, again, in this presentation, what I'm talking about is the sort of the sorry, I'm stuttering because my FSD is following a car that is driving in a weird way, and it's interesting to see how the tech is dealing with that. So this is a human in front of me. I believe it's driving some cheap Asian car. So this is definitely a human, not some AI. And they're driving very weird. And my FSD is very cautious, very cautious. Like I don't know if this is an emergent factor or whatever that is. It's just it's very uncomfortable to be exposed to weird people and weird drivers, and you can see how the software is dealing with that. I had to intervene because again this became a little bit tricky, and if something is unpredictable to a human, I can't expect FSD version 12 to do a better job than me. So back to the talk. So Kaiming He is talking about representation. Again, why is representation key? Well, he's kind of giving us the fundamental concept. The fundamental concept is we have a bunch of data, let's say pixels, and we have to find representation. So what neural nets do, what this function approximators, which is what neural nets are, what they do is they try to find suitable representations of the data to solve tasks. And for example, in the classification task, so when AlexNet was built, which was a version of LeNet being the first convolutional neural net, I think developed by Jan LeCun in the late 80s at Bell Labs. So what AlexNet did, it won ImageNet. So the algorithm was designed to represent pixel data in the most optimal way so classification can be done. So this is the idea, which is already, tangentially going towards the idea of meta learning, because what you want is an algorithm that can sort of task specifically represent data in different ways. So for example, if we are trying to do classification, we're gonna look for edges and features that are very specific to the pictures so we can recognize them. If we do word prediction, that whole thing changes. And I guess you see where I'm going with this. What transformers have done is, and Kaiming kind of mentions that at the end of the talk, what transformers have done is found a way to generalize across many, many different tasks. This is what transformers have done. That's why they're so amazing. That's why self-attention and cross-attention are so amazing. Actually, transformers are just convolutional neural nets where every patch or every token or every unit of analysis, if you will, references to itself and all the other, at least most relevant unit of analysis, patches or tokens, and develops hierarchies, develops multi-dimensional distributions of where that particular token, let's say token X, which relates to all the other tokens in the input data, where that token belongs probabilistically what kind of distribution it belongs to, and from that distribution we can then draw samples and generate stuff, or classify, or drive a car. What is the car doing? It's predicting the next move given the pixels that it's looking at. So actually, to use the self-driving car example, what Kaiming is saying is, look, what we're trying to do with the self-driving car is we need to represent the data that it's seeing. So the car is seeing something, it's seeing pixels, video data, and it needs to find the best possible representation. And people have, found really interesting ways to represent the data. For example, they found occupancy networks. So what they said is, for example, they said, okay, we can maybe find a very efficient way to see how the nature around us is occupied. It doesn't really matter what it is. So the self-driving car doesn't have a image classification task in the sense that it has to understand whether there is a cat or a fox. All the car needs to do is understand that there's an animal, and the occupancy network does a very good job in that. So you can already see where this is going. We have a representation. Again, let's talk about Kaiming He's presentation here for focus on that. So again, we have this idea of representation being the key, and Kaiming is going through the history of these representations, which the convolutional neural net, this power of the convolutional neural net is that it looks for symmetry in the data. That's really what it does. The way it works technically is you have let's say a square picture of you take a picture, let's say you take an image, and which is a square, and it's separated in patches, maybe pixels, or maybe 5 by 5 pixels or something like that, depending on how you define patch. And what you're going to do with the convolutional neural net is you're going to kind of slide over the window. Think about it. Imagine if you had a filter which did that. Takes 5 by 5 patch of the, let's say, 16 by 16 picture, and you slide it by one, and then slide by one, and so on and so forth. What you're going to get if you do that is you're going to find edges. And then you feed that to the first hidden layer. And then you take the first hidden layer, do the same thing to the second hidden layer, and you're going to then build maybe a higher representation from edges. You're going to get to contours, and finally to some sort of feature, and eventually you will be able to define, let's say, the difference between a cat and a dog. So again, you're starting with you're trying to find the most optimal representation of the data that fits your task. Now, the reason I'm so excited about this is because I'm reading a book which is completely unrelated to Kaiming He's presentation or anything which is happening today, because the book was written 20 years ago, and it's called I'm a Strange Loop by Douglas Hofstadter. And Douglas talks about the same concept, which is we have this lower level representation in reality, meaning lower level, meaning reality consists of protons and atoms and sound waves and light waves and all kinds of stuff. But we humans have evolved into some sort of higher level representation. So we've been able to intelligently find higher level representations of that data. So then when we talk about nature, we don't talk about the constellation of atoms in a forest. We just call it a really beautiful forest with large trees. We actually call them redwood trees. So we find, language is just another higher level representation of a tree. A tree is a higher level representation of a piece of wood that is in something that we call a forest. So you can already see where this is going. We have this, we have these representations, all of which are, really hierarchical in a sense, but they're also kind of self-referential. So a forest can be hierarchical, or it can be cross-correlated in the sense that if I say a tree is part of the forest, and the forest is part of a landscape, but then I can also say the forest feeds the tree, and the tree feeds the forest. So in that sense, they're not hierarchical anymore. So that's kind of a cross-attention, and transformer technology does it. It takes different representations for different tasks again. So having said that, I think what Douglas is saying is really what Kaiming He is saying. And I'm always very excited when two completely unrelated people come and say the same thing. And the reason they're unrelated is simply because temporally they're completely. When Douglas wrote his book and when he wrote Good Leisure Bach, I'm not even sure Kaiming He was alive when he wrote this, so he must have been very young. So it's not like they were sitting together and feeding each other. Now, it's possible that Kaiming read Hofstadter's books and got inspired and all that. He's not mentioning that, but that doesn't really matter. The fact is that the science, the engineering, and technology is going exactly where Douglas was predicting it to go, which basically what he's saying is that intelligence is this ability to have a loop, okay, a loop in a sense that we have, let's call it forward-backward propagation. Douglas calls it a loop. Doesn't matter. It's something which kind of feeds on data, and through that starts representing what it sees in nature, and through that gets better and better and better and develops intelligence. And what's also interesting is Douglas actually mentioned some of the problems with that. One is this risk of amplifying, or either way, too much or too little. Like, one piece, let's say one pixel of a large image could take over the whole thing, right? Kind of in a maybe in a virus type way. You can breathe in air, and there's a lot of air molecules, but there's like one little virus, and that thing has the ability to kind of loop itself in your lungs and create havoc, and that's what COVID was. So in that sense, what we found, and Kaiming's presentation is all about how algorithms were developed, in particular ResNets, so residual networks, and then how regularization and initialization and batch normalization and all these things are necessary to prevent certain inputs to take over the network and disturb the learning process. So this is, to me, really fascinating how he's kind of anticipating in a conceptual way, in a story, in a book, what actual researchers decades later, AI researchers actually were doing, which is again deal with loops and make sure that those loops stay within certain confines. Because here's why: deep learning is about data-driven pattern recognition, and most fundamentally, the idea is on the emphasis on pattern recognition. It's not, nobody cares whether a pixel is red or how red, if it's more red or less red. What we care about is how it relates to its neighbor and its nearest neighbors, and maybe even to pixels which are a little bit further away. It's the relationships that matter. It's not the absolute numbers. And because of that, we can do normalization, we can do regularization. It's good enough. It's good enough to learn representations. So to summarize, this last part of this episode is about Douglas Hofstadter and Kaiming He, two unrelated people, one sort of cognitive science type researcher and the other an AI researcher, coming to the same conclusion, which is that intelligence is built in looping networks, that those networks are very powerful. They can feed in data, raw data, and develop knowledge from that. But those loops have their risks. To paraphrase Douglas Hofstadter, every loop carries the seeds of its own destruction. So we have to take care of that. And Kaiming goes through a history of how networks have been developed, convolutional neural nets, and the residual neural networks, and then regularization, batch normalization, initialization. All these things are absolutely key in building functioning neural networks. So those loops can be used for powerful technology and what we call AI.